Just like the question of optimization of mipmap filtering that I asked in the beginning of the course, in many technical questions, the answer is often "it depends." So to answer it partially, and hopefully to satisfy your curiosity as to what those red and blue color codes meant, let's get started and break apart mipmaps. Starting off with a blank scene, I just called it sandbox student and put it into the root directory of my assets. I'm going to drop in a few of the models that I have. Let's get started with the one that says metal crate. It's going to be an FBX file. And now I'm going to create a plane. Going to the game object, create other. Scale it up a little. And I'm going to give it a material. This material was not automatically imported from my 3D package, and I created a custom directory for materials, and it's going to be called concrete tiled. I'm going to just give this a somewhat meaningful name, and I'll also need a camera. So game object, create other, camera. Let's move it a little further. Position it so I can see both my ground and the crate. Okay, that's good. And let's drop off a directional light. Okay. That's probably not the most dramatic lighting, but it'll do fine in this educational example. Okay. So before we provide any sort of solutions, it's probably a good idea to know what the problem is. And the one that I'm trying to solve is how to make the texture the smallest size possible, and also how to reduce the jaggedness of the graphic. To show how mipmaps solve both of these problems, let's bring in another model. This one's just going to be called Mipmap EX. And bring it anywhere in the scene. Now, as you can see, talk about perspective, this turned out to be in a completely different place than I thought it would be. Some of the textures are smaller than others. This is not simply the same object scaled down. In fact, it's actually the same model, with some planes being positioned higher than others. To reduce jaggedness or to introduce anti-aliasing and to improve performance, Unity takes textures and it creates this pyramidal structure called mipmapping. So when an object is closest to the camera, the texture will be the largest. When the camera is further, it will eventually break down in powers of 2 and become smaller and smaller. This is great because it really improves performance and it also reduces jaggedness. For those of you that are not as familiar with the concept of anti-aliasing, let's look at this outside of the game engine and inside a two-dimensional image texture in an image editing program. Let's draw a couple shapes. I just have an arrow. Going to draw one with anti-aliasing on, and I'm going to draw a second one with anti-aliasing off. Okay? And in case you're looking at this with a lower resolution, if I zoom in, I immediately see that I have very, very sharp edges up here, and if I zoom in to the other arrow, the one where I had aliasing, you will see that Photoshop will try to smooth out all of these pixels, all of these ladders, and try to make it as continuous as possible. Even though our screen resolution now is getting really high, pixels are still going to be fragments, and in order to provide this illusion of things being continuous, anti-aliasing is still very important. Okay, and we're back. Let's get rid of this Mipmap EX exemplary model by just clicking on it in the hierarchy and then typing Command or Control Delete. We're going to focus entirely on the model and the texture here. The texture that I have applied for the diffuse is going to be the Metal Crate diffuse texture up here. And to demonstrate some of the concepts of Mipmaps, just go ahead and select it in the project folder. Okay, and scroll up a little bit. We see this texture type here. It says texture. Even though in the end we will leave it as texture, go ahead and click on the drop down anyway and choose advanced. What I'm primarily interested here is this generate Mipmaps parameter. Now, if I don't generate Mipmaps and just click apply, what we'll see automatically is that these textures will become right away very, very defined, very pixely. And as I'll scroll out, Unity will maintain the same texture. Now, while using Mipmaps will actually take up more RAM because it has to store more textures, like if you look at the Mipmap crate here, you will see that this is actually a listing of the same image over and over. This is not, of course, you don't have to set up your textures this way. This is simply an example of what a Mipmap would be. But this will take up more space, but this will take a smaller hit on the CPU. Okay, let's get back to this texture up here, the Metal Crate diffuse. So using Mipmaps is generally a fantastic idea unless you're doing something like a graphical user interface in which the graphic will neither shrink or expand. Cool. Okay, so let's click on Generate Mipmaps again, and just to quickly go over the settings, linear space is going to be whether the mipmaps will be generated in linear color space. Border mipmaps are something that are used for light cookies. Mipmap filtering, well, first of all, let's turn this on so we can see the difference. Okay, we immediately see that this gets blurry. I mean, really, it's just using a smaller mipmap. And if we choose mipmap filtering from box to Kaiser, now check out what happens. This is going to get a little sharper, but it's still going to be using mipmaps. So if you find that your textures are too blurry, this might be a good selection. Okay, and lastly is maybe for something like a detail map, if you select a fade out mipmap and you've got a range slider up here and just click apply, you can see once we zoom out, the mipmap will gray out. So this fade range is currently too small. If we apply it further, this will get gray as we zoom out. We're not going to be utilizing this feature in this lesson, but it's a good thing to keep in your pocket. Now, before we're going to switch back to texture up here, make sure to uncheck this option because it actually will carry over. And click apply. Okay, we'll see that the fade out mipmaps is now no longer effective. Our object will not gray out no matter how much we zoom out. Click on texture type and select texture. We're back and just click apply again. Last thing I want to point out is this filter mode up here where it says bilinear, trilinear, or point. Currently, if you see that I zoom out, we will see one of the Mipmaps blur into another one, and there is somewhat of a popping effect. If I choose trilinear, click apply, this is now going to be a lot smoother. So this interpolation of one Mipmap over the other, if this is something that is of high importance in the game, maybe it's worth investing into the higher setting for the filter mode. Okay, let's look at the color coding. Go ahead and switch to default from the mobile compression option. And on the top pane, from RGB, choose Mipmaps instead. So right away, everything turns red. Now, this is Unity's representation of ideal texture size. So it's currently telling us if the camera is going to be this far away from the object, this texture is currently too large. If I zoom in closer, this will turn more and more blue as I go in. And currently it's telling me that it's too small. And I can adjust it all in the compression settings here. So for example, if it's currently blue and I switch it to 1024, right away it turns its standard color. And if I zoom in farther and farther away, it turns red. Unity is once again telling me that this is too large. Now, this is not the gospel. You don't have to follow everything that the color coding tells you, and you can use your judgment and figure out where your camera will be in accordance to the object. So to reduce the size, it's in the inspector, in the texture import settings. If I bring this lower to say 256, okay, this will make the texture size more appropriate to the distance of the camera. Cool, guys. Well, we're going to be coming back to anti-aliasing a little later in the course from a different angle, but as far as Mipmaps are concerned, we've pretty much covered the basics.